this scenario is going to become MPLS L3 VPN. Actually, this is foundation of MPLS L3 VPN. Means connecting multiple sites of
Sir, I
customer
will share
through
your screen, but I
sharing.
can.
No, I'm not sure. Not sure yet. Connecting multiple sites of customer through service provider network using BGP protocol.
Recording, please.
The recording is started.
Thank you.
Scenario is connecting how to connect multiple sites of customer, same customer or multiple customer. Doesn't matter. Later you will learn the VRF. In the VRF you will see how service providers are going to separate the prefixes of multiple customers. For now, just assume we have one customer and they have multiple sites. How we are going to connect multiple sites together through service provider network. And here is my topology. Let me share my screen. See, let me know if a screen is visible.
Yeah, it's visible. It's
Yeah, it's
perfect.
visible. Yes.
First of all, see here in this topology, I have two sides of one customer. Customer is side 1, customer is side 2. A single prefix in both the side. For testing, this is sufficient. And identify the routers here. That is very important. Identifying routers. Why we called R1 is PE router. Why we call router 2 is PE router only. PE2. P stands for provider edge router. P means provider router. And here is C1, C2. What is C?
Customer edge.
Customer edge
Customer
router. In the service provider network, you can see I am running IGP protocol OSPF. What is the purpose of this OSPF routing protocol? OSPF is not running to advertise customer prefixes. Service provider is using OSPF for internal reachability, right? For reachability between P1 to P2. What I have told you that in service provider network, there will be lots of router, multiple path can be there from one P to another P. We can have lots of path between two P routers, and two P routers will be reachable through OSPF dynamic routing protocol, like let's say R1, R3, and here I have R2 and R4, kind of like this. So between 2P you can see I have two path. You know the importance of having BGP session between router 1 and router 3 between P through loopback. Right? Should I configure BGP session between R1 and R3 through physical interface IP address? What will happen if I will configure BGP session through physical interface IP?
Session won't come.
Then BGP session will work on one path only, right? If R2 will goes down, BGP session is down. Now if I will configure BGP session with the help of this to loop back here BGP, the until and unless one path is active between R1 and R3 between two P router, BGP session will be up, right? BGP session will be up between two PE router, right? Here I can have other path as well, some more path. Doesn't matter how many paths are there between two PE router and how they are reachable with each other, right? So you are running OSPF, you already know the OSPF routing protocol. You already know how router like 1.1.1 and 3.3.3 are reachable with each other with the help of OSPF routing protocol. For reachability also you can perform manipulation in OSPF. You know that manipulation also. If I want my BGP session should be on this path, if this path is up, this is my best path, we can do the manipulation of OSPF inside the MPLS cloud, service provider core network. This is service provider core. But to advertise the customer prefixes, like from one side to another side, from one P to another P, to advertise the customer prefixes, we have BGP session, IBGP session, right? So customer customer CS1 is going to advertise prefixes to PE router, and PE router will advertise this directly to remote side PE router, PE2, remote side PE router, and then remote side PE router is going to advertise prefixes to remote side customer edge router. Router 2 will not have any customer prefixes in their routing table, and definitely this router should not have customer prefixes in their routing table. Otherwise, these all routers are going to install customer prefixes, right? The later you will see provider can connect multiple customers, right, in the same network, in same MPLS, sorry, service provider core. And multiple customer can also use same IPv4 address, right? IPv4 address is reusable. This is private address. Private IP address is reusable. Within the organization, IP address should be unique, but let's say there is another organization, customer B, customer A and customer B. Customer B can also use same IPv4 subnet inside 1 and same IPv4 subnet inside 2. Right? Why I'm saying this is foundation of MPLS L3 VPN, because later you are going to learn more routing protocol, actually BGP only, but more than BGP. Between 1.1.1 and 3.3.3, you are going to configure more than BGP, that is MPBGP in the same scenario, right? So this topology is the foundation of MPBGP as well. If I am running MPBGP here, MPBGP, BGP. Now maybe you don't know the MPBGP, later I will talk about it. Today we'll understand the route exchange and data exchange between two sides of customer A through service provider network. If you if you know all the BGP rules, you can understand after configuring BGP here everywhere, like after having IBGP session between 1.1.1 and 3.3.3 and EBGP session between .1 and .4, and here also between .3 and .5 EBGP, why customers are not exchanging routes, or why we are not able to find the side 2 prefix in side 1 or side 1 prefix in side 2. Again, that doesn't matter how many prefixes we are advertising. So keep in mind about OSPF routing protocol here is we will never advertise this link into OSPF routing protocol. We will not advertise this link into OSPF routing protocol. Here we are running BGP. OSPF, where you will configure OSPF on R1 on this interface, which is connected with P router, and on your loopback interface, so that router 1 can discover neighbor here and it can advertise this loopback submit to their neighbor, and then router 2 can advertise it to R3. So on router number 3 also I will enable OSPF on G0/0 and loopback. On R1 G0/1 and loopback. Here I have, yes.
Sir, one question, sir. It is not related to BG, but suppose we are having a private network, then we should run NATing on the CE or this PE?
NATing?
Because
What is NAT?
this private, it will address translation, means like we will private to public or public to private.
Where is public
So,
IP address?
maybe on the service provider they will be assigning a public IP address to
No,
the CE
nothing.
router.
Nothing is like that here, right? We are just connecting two sides through service provider network. Here we don't need to configure NAT. NAT is used to access internet. Here we are not talking about internet access. Okay?
Okay.
Sir, can we just once describe the scenario once, just a quick?
The scenario is simple. Here you can see one customer has two sites and both the sites are connected through service provider network.
Sir, I don't know it's a relevant question or not. What is C or P here? Means
Provider edge
what is
router. The router which is connecting customer and provider network. That is called P router.
okay? So okay.
Anything else in this scenario? If anything is not clear, please ask.
Yes, sir. Praphul. What about in the situation where the customer is not physically connected to the ISP?
What about?
A situation where the customer is not physically connected to the ISP router. What I mean
Customize?
is that the customer have a public IP address which the service provider give him, and they are not physically connected.
Where it is connected?
Is it possible to connect the two router through the internet?
Two router through internet.
Yeah,
Okay,
using
so
public IP address.
okay, let's suppose this is R1, one customer C router. You will connect C router to internet and then
Yeah,
internet to service provider router.
exactly.
P router.
Exactly.
No, we are not going to connect it like this. This is incorrect scenario, right? That is connecting multiple sites through internet. See, I have two sites, site 1 and site 2. I can connect these two sites through service provider, through ISP, broadband, right? Multiple types of WAN we have here. I am using what? SP, right? I can have ISP as well. Here I am using public IP address. Here I am using public IP address. Again, you will create VPN here, GRE VPN or IPsec VPN. I am talking about this WAN, service provider WAN. So we don't have any internet here or public here, public network here. Customer is directly connected with provider router.
Okay.
Anything else?
No, it's okay. It's okay now.
This is what? This is private WAN. This is not public network. This is what? Private WAN. There is some difference between SP and ISP. Put yourself on mute, getting noise. Don't mix SP and ISP, both are different. SP is service provider, ISP is internet service provider. SP, when I am saying SP,
No, I don't want both.
when I am talking about service provider, it only provides connectivity between two or more sites, between two or more private sites. Whose mic is? Bro, I am requesting you to put yourself on mute. You are not alone in the class. Bangura, clear? If there is noise, keep yourself on mute. Okay? So this is not ISP, this is what? SP. It is not providing internet access. Still, after making connectivity, users in side 1 cannot access Google, cannot access cloud. They can only talk to side 2. They can only talk to side 2 users. Okay, anything else? Any question in C1, C1, C2, P1, P2 and P?
In which use case we use this scenario?
Everywhere we use this scenario only to connect multiple sites.
Like
PM networking. Let's say PM networking has 2 branches, one in Surat and one in Delhi. I will use this scenario to connect both branches together. PM networking has 2 sites, one in Surat and one in Delhi. How I will connect these 2 sites? Through service provider network. I will purchase connectivity from Airtel. Airtel is going to provide connectivity in Surat as well as in Delhi. And this is how service provider like P1 and P2. This is how P1 and P2 are directly connected.
Then it's like a dedicated lease line kind of thing.
Huh?
Is it kind of dedicated lease line
absolutely.
between? Okay.
It is similar like leased line.
Therefore, it is very expensive, right?
Definitely, it is expensive. Anything else?
Then we will also see the ISP scenarios also, right, in future?
Yes, definitely. Clear, everyone? All good? Tell me why we are using OSPF here? Why not EIGRP?
Faster conversion.
You guys should ask these types of question. So no one is asking this. Why we are using OSPF only here? Think about this, right? Why we are using OSPF? Why not other routing protocol?
Maybe some other customer also are not having Cisco's routers with them.
I don't think EIGRP is Cisco proprietary protocol.
And okay,
We can use both.
we have bigger
It is small
area, we have
topology.
bigger, because
Definitely we can
ISP is
EIGRP
Both.
also, but we know the advantages of OSPF over
Yes.
EIGRP: fast convergence, view,
Yeah.
complete topology, complete view of topology, simple routing, scalability, right? And OSPF, we are running IGP just for underlay connectivity. Just for underlay connectivity to make reachability between these two. Look back between P to P, so that P1 can reach to P2, right? P1 is at different location, P2 is at different location. Okay, and here even if someone is thinking in future BGP can replace OSPF here, no neighbor. BGP cannot replace OSPF, because what we need here, we need a fast protocol. We need fast protocol. This is traveling inside the city, right? Inside the service provider network, we are making reachability. So OSPF is the best routing protocol here. Why IGP here, IBGP here? Why IBGP between P to P? You know, only BGP is the
Within the
protocol.
same AS.
Only BGP is the protocol which can advertise prefixes between R1 and R3. Routers are not directly connected. What IBGP is doing here, it is advertising customer prefixes from one location to another location, right? P1 is going to learn routes from customer 1, C1 means customer A side 1, and it will advertise to other P. P2 is going to learn customer route from P1, customer side 1 route from P1, and then it will advertise to other side C router. And here whatever rules,
we don't run entire like that IBGP, because PE1 should only give prefix to PE2, so that other router between they should not be aware about what is the routes are being going. So that's why we are running IBGP.
correct.
Otherwise, OSPF would give all the routes to every router.
Correct. And why not EBGP here?
Where, sir? Where?
Here.
They're the same autonomous system.
Same service
You will
provider.
have EBGP as well, right? Here I have same service provider. Let's suppose in Delhi, this is Delhi side and this is in Surat. In Delhi, I have connectivity from Airtel and here from the Jio. Maybe they will be using EBGP. Right now, service providers are going to
Yes.
exchange, customers are going to exchange routes through service provider, and you can see service providers are also exchanging routes. There will be some mutual communication between Airtel and Jio, between these two service providers. You know, all the service providers are also connected together. That is only internet. Network of networks is internet. Okay, done. Let me show you the initial configuration here. On router number 1, you can see I'm just configuring first OSPF router ID. After that, I have configured G0/1 interface. 0/1 is connected with provider router. right? It is connecting R1 P1 is connecting customer network to service provider core network R2P router. So you can see just have enabled OSPF on this interface and I have configured IP address 12.1.1 on G0/0, which is customer facing interface. You can see this interface G0/0 of R1 P1 is connected to customer. This is customer facing interface. On customer facing interface, I have not enabled OSPF. OSPF is not, just I have configured IP address, nothing else. Then I have created one loopback 1.1.1 and again I have advertised this loopback into OSPF. Let me copy the command and let me paste it on R1. All the commands are accepted.
Quick question.
Go ahead.
On PE1, are we using the 14 IP? Is it a public IP? For example, here?
Where? What I told you, this is private cloud, bro. Private cloud. Doesn't matter what is the IP over here, private and public. Right?
I'm trying to understand because bringing connection to the
Over private cloud, you will be using private IP only. Public IP is for public cloud, public network, ISP.
where it lies in this design, then can you please
We don't
just
have
point me out?
public IP address anywhere here.
Okay.
Everywhere we are using IPv4 private IP address.
Internal network. Okay.
Internal?
This is somewhat like MPLS, right? This design.
Yes. This is foundation of MPLS.
Okay.
Then here is the initial configuration of R2 underlay configuration. Again, you can see I have configured OSPF router ID. I have configured IP on G0/0 and 0/1 and just enable OSPF and change the OSPF network type, nothing else. Copy and paste on router number 2. After that, I have same configuration for R3, similar like R1. You can see, okay, R3 host name R3, OSPF router ID is 3.3.3, interface G0/1. This is customer facing interface. I'm not going to enable OSPF over here. IP address is going to be 35.1.1.3 and G0/0 is connected with provider router R2. Here IP address is 23.1.3 and I will enable OSPF. Also I will configure network type. Network type point to point, IP OSPF 1 area 0 and finally loopback 1 3.3.3 and I have advertised this loopback into OSPF. By the way, here we have configuration of R3. Let me copy from here and let me paste it. Let me remove this command. R3. Copy and paste it. Now I am expecting connectivity between 1.1.1 and 3.3.3. You can verify the routing table. So IP route OSPF, you can see till now I have not learned 3.3.3. Soon it is going to learn 3.3.3. So IP OSPF neighbor, good, go to R2. So IP OSPF neighbor, you can see R2 has 2 OSPF neighbor and both are in full state. As I have configured network type point to point, we don't have any DR/BDR. In the database of OSPF, you will only have router LSA on R3. So IP route OSPF, you can see you are learning 1.1.1 and on router number 1. So IP route OSPF, you are learning 3.3.3. You can check connectivity ping 3.3.3, source 1.1.1 and you can see ping is working. Now I can configure BGP.
IBGP.
Now between
Between the
1.1.1 and 3.3.3, I can configure BGP session because reachability is there. Before that, let me configure customer edge router also. For customer is router R4, we'll have configuration what interface, or let me copy the configuration. Not going to enable OSPF, remove these commands. Enable host name R4, interface D0/0, 0/1 will have IP 14.1.1.4. On router number 1 I have configured 14.1. Yeah, correct. Okay, and 0/0 will have IP, no OSPF, remove these two commands, and here change the IP address 192.168.1. Let's say 100 or 1, any IP address. This is my IP configuration for R4. Copy it, paste it on R4, and R5. R5, host name R5, IP on G0/0, 0/1 is going to be 192.168.2.1, and 0/0 will have IP what 35.1.1.5. R5 configuration. Let me copy the command R4, paste it over here. What happened? There is some error. Enable config T host name. Okay, copy and paste now. All commands are accepted. Let me copy commands of router 5, R5, and let me paste it here. Done. We are done with basic configuration, initial configuration of this scenario, which we have already discussed in previous classes. I'm expecting you all know this configuration. Now let's configure EBGP session between customer edge and provider edge router first. Go to R4, say router BGP AS number. See what is my AS number? 100, right? Inside 1 and side 2 my AS number is 100. In service provider network I am running AS number 500. Router BGP AS number 100. Neighbor 14.1.1 and remote AS 500, and I will advertise one network 192.168.1.0/24. Mask 255.255.255.0.
Sir, I have one question, sir.
Yes.
So this CE side, this customer side AS number, this AS number also been provided by the service provider, or customer can configure its own AS number, because service provider has to manage all this AS. If somebody else also having same AS number, it will be confusion. So normally, who is to provide this AS
Okay,
number?
service provider can also provide AS number here, and you can also decide your AS number.
Okay.
Okay, so IP BGP. In BGP, it has installed this prefix. Now it is going to advertise to their neighbor. So IP BGP summary. Router number 4 don't have any BGP neighbor. You can see status is idle. Let me take you to R1 and let me enable BGP 500 here. Router BGP 500 and neighbor 14.1.4 and remote AS 100. Now we will have BGP session.
Sir, you are on R5.
No router BGP 500 on R1. Router BGP 500 neighbor 14.1.4 and remote AS 100. Now I am expecting BGP session between router 1 and router 4. Here you can see the log message. So IP BGP summary. Good. P and C as BGP session. Receive route is 0. Receive prefix receive is 0. Why R4 is not advertising? Maybe this prefix is still not best. you can see 192.168.1.0 is only valid, not best. So IP interface brief exclude unassigned. IP address is configured on 0/0 interface and port is up. It will take some time, so IP BGP. It will take some time. After that, this prefix is going to become best. Till then, let me configure BGP session between PE2 and CE2. Go to R5, router BGPS number 100 and neighbor 35.1.3 and again remote AS same 500. Go to R3 and on R3 enable BGP 500 neighbor 35.1.5 remote AS 100. Again I am expecting BGP session here. Now in the BGP table of R5 you can see this LAN is valid as well as best. This prefix is valid as well as best and next hop is 0.0.0. What is the meaning of next hop 0.0.0? It is self-advertised prefix. Now R4 will advertise it to their neighbor. Question is, okay, so IP BGP done and so IP BGP summary. Who is neighbor? 14.1.1.1. Neighbor is directly connected, correct? On router number 4. So go to router number 1 and check BGP table. So IP BGP. You can see it is learning one prefix, right? Even if you will check neighbor, you can see neighbor is 14.4 and prefix receive is 1. It is receiving 1 prefix. So IP BGP in BGP table you can see 192.168.1.0 prefix is valid as well as best. And next hop IP address is customer WAN port IP address. WAN interface IP address 14.4. 14.4 is reachable from R1. R1 is going to install it in their routing table, you can see. Similarly on router number 3 also I am expecting one dot show IP BGP. So IP BGP summary. Neighborship is up but prefix receive is 0. I think here on router number 5 we have not advertised the prefix in BGP, correct? Router BGP AS number 100 and network 192.168.2.0 mask 255.255.255.0. So IP BGP. Now you can see it has installed this prefix in BGP table. It will advertise to their neighbor. So IP BGP summary. Who is neighbor? 35.3 router number 3. Go to R3 and check BGP table. Now you can see it is receiving one prefix from this neighbor and so IP BGP. In same way here you can see the one entry 192.168.2.0. Next of IP address is again customer WAN port IP address 35.5 and this IP address is reachable. Good. Both the customer edge routers are advertising prefixes to provider edge router. In MPLS WAN, how we perform routing? Customer edge routers advertise prefixes to provider edge router. And between PE, they will exchange customer prefixes through IBGP. So let's configure IBGP session between R1 and R3 now between two PE. Otherwise, you can see on router number 1. So IP BGP, we don't have 192.168.2.0 customer side 2 prefix because we don't have any BGP session and we are not going to advertise it into OSPF. If I will redistribute this BGP route into OSPF, then definitely PE2 will learn this through OSPF, but all provider router is going to learn it. All provider routers will also learn customer prefixes. So we will not do that. We will not redistribute BGP into OSPF and will not advertise this into OSPF routing protocol. Let's configure BGP IBGP session. Router BGP AS number 500. Address family IPv4 unicast and neighbor 3.3.3.3 and remote AS. See, if you don't know address family, for now you can leave. If I am not going to define address family, it means we are configuring inside address family IPv4. right? Later we'll use address family. At that time I will talk. Now BGP 500 and neighbor 3.3.3 and remote AS of neighbor is 100 only. Do I need to enable any other command here? Need to run any other command on R1?
It's fire.
The neighbor
That's
500, right?
Update source loopback neighbor 3.3.3.
Yes.
Update source
Update
Sir,
source
back.
record.
so remote is 500, right?
Hmm?
Remote is also 500, right? Because IBGP.
Remote AS is 500. Anything else? No. Go to R3 and let me configure BGP 500, router BGP 500, neighbor 1.1.1 and remote AS again 500 and neighbor 1.1.1 update source loopback 1. Will I have BGP session? Will my BGP session come up? So IP
Maybe yes.
BGP summary, you can see, right? One neighbor is 1.1.1 on P2 on R3 and one neighbor is customer is router. One is remote side P, one is customer. Great. Now from both neighbor it is learning one prefix. Here you can see from 1.1.1 also it is learning one prefix. Prefix receive is 1. Which prefix it is receiving? Side 1 prefix from R1. So IP BGP, you can see 192.168.1.0 coming from 1.1.1. And what is next hop IP address? 14.1.1.4. This is customer edge WAN interface IP address, right? You can see R4 WAN interface IP. Is this IP address reachable from P2? No. Right? IP address of this interface is not reachable from R3. Similarly, IP address of this interface is not reachable from R1. What is happening? R4 CE1 is advertising 192.168.1.0 to their EBGP neighbor with next hop 14.1.1.4. When R1 is advertising to their IBGP neighbor, it is not modifying next hop. It will not modify next hop IP address. It will advertise 192.168.1.0 with same next hop 14.1.1.4. And that IP address is not reachable from R3. That's why this prefix is only valid, not best. And if prefix is not best, only valid, then router is not going to install it in routing table and it will not advertise to any neighbor. So IP route BGP, you can see in BGP it has not installed side 1 prefix. How I can update next hop here?
Next hop self command, or can put the route map.
Only next hop self command here, right? On P router you will run next hop self command for remote side peer neighbor 3.3.3.3 next hop IP next hop. What is command? Neighbor next hop. I am on router number 1 neighbor 3.3.3. What was the command?
Use others family.
Next hop self. And on router number 3 also router BGPS number 500 and neighbor 1.1.1 next hop self. On router number 1 I had configured address family, that's why command was it it was like not accepting the command. Now if I will clear BGP's table here, clear IP BGP star soft in and show IP BGP. Now you can see router 1 has updated the next hop IP address, right? Who is advertising this prefix to R3, R1, P1 router? Next hop IP address is now 1.1.1. Very good. And on router number 1 also you can check show IP BGP 192.168.2.0. Next hop IP address is 3.3.3. Great. 3.3.3 is reachable. That's why this prefix is valid as well as best. Now R1 is going to install it in their routing table. So IP route BGP, you can see site 2 prefix and it will advertise to their neighbor. So IP BGP summary, it is learning 192.168.2.0 from 3.3.3. From IBGP neighbor, it will advertise to EBGP neighbor. Will it modify next hop?
Yes.
Definitely will modify the next hop. What will be next hop?
The G00.
14.1.1.1. 14.1.1.1.
Yeah.
1 and 14.1 is already reachable from R1. Here you can check. So IP BGP neighbor 14.1.4 advertise route. You can see R1 is advertising site 2 route to C1 router. Site 2 route into side 1. And next hop on R1 is 3.3.3. But let me take you to R3, R4 and let me show you BGP table. So IP BGP, here we are not receiving. Here we are not receiving the so IP BGP neighbor 14.1.1 and receive route. Receive route. Receive route. Now you can see receive prefix is 0. So R1 is advertising, but on R4 you can see receive route from this neighbor is 0. We are not receiving any route. Why? Because of loop avoidance mechanism of EBGP Praphul. When R1 will advertise side 2 prefix to R4 C1 inside 1, there will be ES number 100, right? Or you can understand like this from this way. When R1 is going to R4 is going to advertise it to R1, will it include ES number? Yes, it will include ES number 100. When R1 is going to advertise to R3, there will be ES number only one ES 100. When R3 will advertise to R5, it will include ES number 100 and 500. Now when R5 will receive this update message, it will find their own ES number, it will drop the update. Same thing is happening. Here we have to run allow ES in command. Go to R4. Say router BGP ES number 100 and neighbor 14.1.1.1 allow ES. I'm on which router? Okay, on R4. Neighbor 14.1.4 allow AS in, and after running allow AS in command, clear IP BGP. So IP BGP. Now you can see on router number 4 we are able to see site 2 prefix 192.168.2.0 and next hop IP address is 14.1. This IP address is reachable, and here you can see in AS path we have two ES number 500 and 100. Now prefix is valid as well as best even through receive route. Now you can see it is receiving this route, right? This route is valid as well as best. It will install it in their routing table as well. Now inside 1 we are able to see site 2 prefix. Similarly on R5 I should have side 1 prefix but you can see I'm not able to see that. Router BGP number 100 and neighbor 35.1.3 allow yes in, and so IP BGP. Side 1 prefix 192.168.1.0. Correct? Now if I will check routing table of side 2 CE2, you can see in the routing table of side 2 I am able to see side 1 route prefix, and in side 1 we are able to see side 2 route. This is how we exchange routes between multiple sites through service provider network. Through service provider. Who is responsible for routing between sites? Service provider only. We are exchanging our routes through service provider network. We are advertising route to service provider and service provider is advertising to other site. Routing is happening through service provider. Here you can have direct link as well between these two sites. Here you can configure one IP, here one IP, and you can configure routing. Right? You will have entire control on the routing between two sites. But here routing is happening through service provider network. But okay, route is there, but can ping work? Can I send traffic inside 2.1 source 192.168.1.1? Ping is not working, right? Is there any issue of customer router configuration? No. Right? If route is present in the routing table of customer router, that means our router is configured properly. There is no issue on customer is router. Now it's responsibility of service provider how they are going to forward traffic between these two sites. This was route exchange. Now there is another thing, that is traffic forwarding, packet forwarding. So packet is still getting dropped because in the service provider network you can see on router number 2 we don't have route for customer sites. So IP route 192.168.1.0. No. P router, all P router, provider routers don't have information about customer prefixes. So in the service provider network, they are going to use another technology to forward the packet. To forward packet, they are going to use another technology, that is MPLS. That is MPLS. To forward the packet. To exchange route, you know how they have configured the BGP. Now in MPLS cloud, I can enable MPLS router OSPF 1 and MPLS. Keep yourself on mute. Interface G0/1 MPLS IP. Right? This is command to enable MPLS on interface of router. Right? It will, as soon as you will enable MPLS, it will start maintaining one mode table. I will discuss about that table in MPLS. On router number 2 also, go to router 2 and say interface range G0/0 and G0/1 MPLS IP. They will have LDP neighbor. Okay, later you will learn LDP protocol. Similarly on R3 also interface G0/0 MPLS IP. If you will check
one more way we can redistribute, but which is not advisable in service provider network.
Yes.
Yeah. Okay.
So IP route 192.168.1.0. See, provider routers still don't have information about customer prefixes, but now if you are going to ping, then see ping is working. Between branch 1 and branch 2 we are able to exchange data. Right? So my IBGP.
So we just enable that IPMPLS on R1 only? Or,
I have
sorry,
enabled on R1, R2 and R3.
Okay.
BGP helping customer to exchange routes, and MPLS is forwarding packet. Even if you will trace route from here, trace route 192.168.2.1 and source 192.168.1.1. Traffic is going to 14.1.1.1 R1. After that you can see 23.1.1 23.1.1.3 R3. We are not able to discover R2, right? It means what? It means there is VPN between R1 and R3. My traffic is going through VPN. Yes, this BGP is IBGP session is working as an overlay running on top of your physical network on underlay. What TTL value is required to send traffic in side 2 from side 1? What should be the minimum? What can be the minimum TTL value to send traffic in
One,
side
right?
2?
One only.
If user will generate traffic with TTL value 1, it will become 0 on R4. It will discard it.
2,
If it is 2,
EBGP.
then R1 is going to discard it.
3. 1.
But EBGP TTL value is one, right?
Okay, you can
It has
assume
to be
like router
5.
1 and router 3 are directly connected like this. You can imagine it like this. 4,
It has to be 5.
okay.
4.
For this customer A, right? Similarly, this service provider can have one more customer B side 1, customer B side 2, same on the same P router on P1. You can see I have 2 customer. This customer will also advertise prefixes to P router. P router will advertise it to other P router. Here you have to create one more BGP session for customer 2. But how we will forward or exchange routes of both customer through single BGP session is nothing but MPLS L3 VPN. That will be discussed later. Any question here to understand this basic connectivity between these two sites? Don't worry about the MPLS forwarding, how MPLS is forwarding the traffic. You will understand it.
On R2 router, you configure only OSPF, right?
Yes. Now you can see your core network MPLS cloud is BGP free for stability. If there is any fluctuation on R2, no problem. It is not going to impact BGP protocol here, right? That's why we are not running BGP on provider routers. BGP is running between P to P. If you have made reachability or have exchanged the routes between side 1 and side 2 through service provider, you have covered all BGP rules, basic rules. Next hop, and in the last class we had also seen route reflector to avoid to actually advertise prefixes from IBGP to other IBGP, from one IBGP to other IBGP. And this is all about basic BGP. Now we need to understand best path selection in BGP, similar like other routing protocols, OSPF, EBGP. Like that, best path selection. Can I turn off this lab?
And in this lab, I see that we have local preference value also. How we got this local preference here? We haven't configured it.
We are going to understand local preference value. We don't need to configure any local preference value here.
Sir, on this lab, the R2 is down. If R2 is down, so the BBC, that BGP session is still there from R1 to R3, but the traffic is not passed from the edge router to edge router, CE router to CE router. It is correct?
If R2 is down, then BGP session will also goes down, no bro? If reachability between 1.1.1 and 3.3.3 is down, then BGP is down.
Okay, understood. Thanks.
Anything else, guys? Can I turn off this lamp? Clear?
Yes, sir.
R1, R2, R3. First of all, tell me one thing. If I have IBGP session between R1, R2 and between R2 and R3, here we have IBGP or okay, forget about IBGP session as well. These are 3 routers in the service provider network or in my company only, and I have some LAN on router number 1, some prefixes 10.1.1.0/24. Through IBGP, how I can advertise this to R3? Let's say AS number 100, AS number 100 and AS number 100. If I am running same AS number on all the router, and here I have IBGP session, here also I have IBGP session, will all R3 have this prefix in their BGP table? 10.1.1.0?
No.
You will configure
No.
what?
Until that
Route
client
reflector.
you can configure.
Route reflector. And
Yes.
if you are
Yes.
not allowed to configure route reflector, then how you will advertise this prefix to R3?
Indirect neighborship we can create, right?
Then you have to create full mesh topology. R1 will have
Yes.
BGP session with R2 as well as with R3,
3.
right? We have one BGP session over here. R1 has one BGP session with R2, and it will have one more BGP session with R3. Now R1 is going to advertise this prefix to their both neighbor, R2 as well as R3. You can do this as well if you want to avoid route reflector. Okay, if I want to configure full mesh topology here, full mesh BGP here, how many commands I need to run on R1? First command, tell me all the commands on router number 1.
We need one link also. We need to. Are we creating one more link, or we are doing the underlay of OSPF and
Router BGP
configuring?
100, neighbor let's say 2.2.2, remote AS
100.
100, neighbor 2.2.2, update source,
Loopback 1.
neighbor to, if you want to configure password for the neighbor to secure BGP, you can do that as well. Neighbor 2.2.2 and password Cisco 123. Then neighbor 3.3.3, remote AS 100, neighbor 3.3.3, update source loopback 1, neighbor 3.3.3, right? And you will have some policy as well, like route map with neighbor. You will have some policies as well. I need to run similar command on other routers as well, like on router number 2 also, router BGP 100, neighbor 1.1, remote AS 100, neighbor 1.1, update source back 1, neighbor 1.1, password Cisco 123, neighbor 3.3.3, remote AS 100, neighbor 3.3.3, update source back 1, neighbor 3.3.3, password Cisco 123. Are you able to see the repetition of neighbor command here?
Yes.
Yes.
Same command for R2, same command for R3. We have how many neighborship here on, let's say, router number 1, 2, on router number 2, 2, on router number 3, again 2. So total 6 neighborship. Total we have 6 BGP neighborship here. We need to run these commands, these neighbor commands on all the routers. To avoid multiple neighbor commands in BGP, we have one feature that is called peer group. That is called BGP peer group. You can simplify this configuration. Peer group is nothing but used to simplify the BGP configuration. This is again one basic topic of BGP. I had forget to discuss it before, so I'm talking about this now. BGP peer group. It is used to simplify the BGP neighbor configuration, means peer configuration. See here, it's clear with their name only. We can create a peer group and we can apply that group for any neighbor. Whatever command you will define inside the group, that will automatically activate it with neighbor. It is going to like this. Let me show you the configuration, then you will understand it in more better way. Router, now see how I am configuring R1. This is one configuration and this is another configuration. Router BGP AS number 100, and here I am going to say BGP neighbor, and name of neighbor is, let's say, IBGP. This is nothing but name. You can configure any name. This is name of my peer. Neighbor IBGP, and I will apply all the commands with this peer group. Like first say peer group. This is peer group, and now I am going to say neighbor IBGP remote AS. Remote AS 100. Then neighbor IBGP update source loopback 1. The neighbor IBGP password Cisco 123. Neighbor IBGP use route map ABC anything. Okay, and now if I need to apply these all commands with two neighbor, to router number 2 and router number 3, simply I am going to say neighbor 2.2.2.2 and use this peer group IBGP. That's it. All the commands which you have defined in this peer group will be activated for this neighbor. Similarly, I will add one more command here, neighbor 3.3.3 peer group IBGP, neighbor 4.4.4 peer group IBGP. So it will activate these all neighbor commands with all the neighbors. So we have feature of peer group in BGP to simplify the BGP neighbors configuration in full mesh topology in complex network. Let's suppose you have a topology like this. In a campus there are 4 buildings, right? At all the buildings I have one router, or in my company there are 4 headquarters, right? You can assume these are nothing but all 4 headquarters. some LANs are connected in all the headquarters. Like here I have 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0/24. Okay, let's say these three subnets on R1 LAN connected on R1. On R2, again there are some LAN 20.1.1.0, 20.1.1.0/24, 20.1.2.0/24, 20.1.3.0/24. Okay, it is like this. Or I have two headquarters, and these are service provider R3 and R4. Here I want full mesh IBGP session. There should be one IBGP session between R1 and R3, one IBGP session between R1 and R4, one IBGP session between R1 and R2. In this case, configuring neighborship through peer group is going to be simple. It can simplify the configuration. Similarly, on router number 2 also I need BGP session like this. Here also like this. This is what? BGP neighborship. Doesn't matter how routers are physically connected, right? For the BGP neighborship, maybe there are some more routers, but still I can have BGP neighbor between R1 and R3. If these R4 headquarters at different location, maybe in between there is service provider. Doesn't matter, but we can configure BGP with undirectly connected neighbor routers as well, right? So on R1 you can see you have 3 neighbors and you need to run 4 commands, let's say, with all the neighbor. Means you need to run 12 command on one router. Even this topology is simple. Only 4 headquarters or 4 sites or 4 routers in campuses. Okay, peer group can simplify the configuration here. Now let's say these two are service provider. Here I have again one loopback on all the router. Loopback 1.1.1. Here my loopback is 2.2.2. Here my loopback is 3.3.3. Here loopback is 4.4.4. Right? You can also imagine like these two are two sites or two nodes in the same campus connected with edge router, C router, customer is, and it is connected with provider edge router, service provider. Two provider routers are there like this. Tata. Or these are my another side, branch 1 and branch 2, and again here I have some LAN. All are real-time scenario only, R4, let's say R5 and R6. Right? These are another sites. Here I have some LAN subnet 50.1.0/24, 50.1.2.0/24, and 50.1.3.0/24. I have some LAN here also 60.1.1.0/24, 60.1.2.0/24, and 60.1.3.0/24. Right? You can imagine like this is one side, this is another side, and both are connected through service provider, or this is your company network and these two are service provider, right? Learning these routes from other side, let's say these routes are coming from DC. All are real-time scenario. If these all are your company nodes, here you need to configure full mesh IBGP, and peer group can simplify your configuration. There is no any other use of peer group. Clear? Peer group concept in BGP. Do I need to configure?
Yes, sir.
Yes, that would be great.
interface G0/0, no need to, okay. OSPF is again required for underlay reachability. On all the router I am going to create one loopback, and for underlay reachability I am running OSPF routing protocol. So keep enable OSPF router, because later we can use this topology for attributes, BGP attributes also for best path selection, because you can see between 10 and 20 there are multiple paths. Here we can see best path selection, router OSPF 1 and router ID 1.1.1. 1 hostname G0/0 will have IP what 0/0 13.1 13.1. G0/1 will have IP what 12.1.2. And here also I need to enable OSPF. Let me copy these two commands, let me paste it over here. And one more interface, that is G0/2. What will be IP on 0/2? 14.1.1. OSPF is enabled, interface loopback 1, IP 1.1.1. Great. This is my R1 configuration. Copy it and I will paste it on.
And after router ID, you need to exit.
I'm not enabling BGP. Just I'm configuring IP addresses and OSPF. Now I will configure BGP through peer group. R1 no, R2 no, R3 no, R4 no, R1 paste the command. All the commands are accepted. So IP OSPF interface brief. And one more thing here, a stint of loopback 1. Okay, no problem. I can create some more loopback 4 LAN interfaces, like interface loopback 10, IP address 10.1.1 255.255.255.0, and I will not advertise it into
OSPF.
yes, I will advertise these prefixes through BGP. Loopback 11 and loopback 12 10.1.2.1 and 10.1.3.1. Now R1 configuration. This is complete configuration of R1. Let me copy and let me paste it on R1, and now save the configuration. Right. For R2, so IP OSPF interface brief. You can see OSPF is enabled on loopback 1 and on these physical interfaces. So IP interface brief exclude unassigned. On these loopbacks, OSPF is not running. For R2, what will be IP on 0/0 interface? 0/0 will have 12.12.2. 0/0. 0/1 will have IP 0/1 24.1.2, and 0/2 will have IP what 23.1.2. Loopback 1 2.2.2, and here 20.1 21.20.1.2.1 and 20.1.3.1. This is my R2 configuration. Copy and paste it on R2. Write the configuration. So IP interface brief exclude unassigned. You can see these loopbacks, and so IP OSPF interface brief. OSPF is enabled on loopback 1 and on these physical interfaces. So IP OSPF neighbor We don't have OSPF neighborship. Duplicate address. So IP interface brief. IP on G0/1 12.2. Correct it. Interface G0/2 IP address 12.1.1 255.255.255.0. IP address is overlapping. Sorry, on not on 0/2, on 0/1. Do so IP interface brief exclude unassign. Now check IP. Okay, now good. And so IP
Membership came up.
OSPF neighborship is up. On router number 2 also, so IP OSPF neighbor. Who is neighbor? 1.1.1. Neighborship state is in full. Good. Good. And so IP route OSPF. You can see through OSPF we are not learning these 10 subnets. These are unwanted prefixes. You can filter it if you want, except 1.1.1. Now for R2 done. For R3, router ID 3.3.3, host name R3, G0/0 will have IP 13.3, 13.1.3, 0/1 will have IP 34, 34.1.3, 0/2 will have IP 23.3. 23.3. Interface loopback 1 IP address 3.3.3.3, IP OSPF 1 area 0, IP OSPF 0.2. And here I am not going to create loopbacks. Let me copy and let's paste it on R3. Then let me configure R4 also. Router ID 4.4.4, host name R4, G0/0 will have IP 34.1.4, 0/1 will have IP 24.1.4, and 0/2 will have IP 14.1.4. Loopback 1 4.4.4. Copy and paste on R4. Okay, I'm going to configure full mesh BGP session here. Go to router number 1, and what I told you for peer group, how you will configure BGP, config T, router, let's say my BGPS number here you can see 100, router BGPS
100.
number 100, neighbor IBGP and peer group. After that, neighbor IBGP, update source loopback 1,
Remote.
update source loopback 1, neighbor IBGP, remote AS
Remote is 100.
100, neighbor
Password IBGP.
IBGP and password Cisco 123. Before this, let me save the initial configuration on all router except BGP. Later we'll use this. Done. Here I have created the peer group, and with the help of peer group I have applied all the commands. Now I will activate this peer group for all the neighbor. What I am going to say, neighbor 2.2.2.2 and peer group IBGP. All the commands are activated. Now on router number 2 also, or here do so history. Okay.
We need to put all the neighbors, right? 3.3 and 4 everything we need to put.
On router number 1, I will activate this with other neighbor also.
Only one neighbor?
will activate it for other neighbors also. IBGP
3 and 4
3.3.3 and 4.4.4. On router number 2, router, or let me do one thing, let me type commands in notepad. Router BGP 100, neighbor IBGP peer group, and neighbor IBGP remote AS
remote is
100,
100
neighbor IBGP update source
updates for loopback 1
loopback 1,
L1
and neighbor IBGP
password
password Cisco
Cisco
1 2
network 1 2 3
3, and then neighbor 1.1.1 peer group
peer group
IBGP, and I will run this command for 3.3.3 also and 4.4.4 also. 3.3.3 and for 4.4.4. Copy it and paste it on R2. Then on router number 3, I am going to apply it with router number 1, router number 2, and router number 4. Copy it and paste it on R3. On R4, I will apply it for R1, R2, and R3. Copy it and paste it on R4. Done. Now see, on any router on R1, so IP BGP summary. It has neighborship with 2.2.2, 3.3.3, and 4.4.4. On R2 also,
but
so
network command we don't interface, right?
hmm?
Network command we interface for 10 and 20.
No, we have not advertised any network yet. On router number 2, you can see neighborship with router 1, router 3, and router 4. On router 3, so IP BGP summary, neighborship with 1, 2, and 4. And on router number 4, so IP BGP summary, 1, 2, and 3. Now on router number 1, I am going to advertise one network. Router BGP 100 and network 10.1.1.0 mask 255.255.255.0. R1 will install it in their BGP table and it will advertise to whom? To all other neighbor. So IP BGP summary, it will advertise to router 2 also, to router 3 also, to router number 4 also. Then when R3 will run it, R3, so IP BGP, it has run it. Now R3, will R3 advertise it to R2 or R4? Will R3 advertise
No.
this?
No,
No.
but we are full mesh, right? R1 directly send it.
Yes.
All will get the route.
Exactly. No, because loop avoidance mechanism of IBGP Praphul, router 3 is server and their both neighbors are non-client. So server router doesn't advertise those prefixes to their IBGP non-client neighbor, which it has learned from other IBGP non-client neighbor. This is rule of BGP. That's why on router number 2, if you will check BGP table, so IP BGP, you can see there is only one path. Only one path, right? This prefix is only coming from R1. Now I want to configure route reflector. R3 and R4 should be my route reflector. Praphul, add one more command here. Neighbor IBGP and route reflector client. So if I am going to add this command, what will happen? This IGP group is
Multiple
already
routes
activated. So their all neighbor will become
process clients.
Their all neighbor will become client. Go to, let me copy command, go to R3 and say router BGPS number 100 and let me add this command. Now go to R2 again and check BGP table. Now you can see this prefix is coming from two path. Next hop IP address is same, because you know when R3 will advertise it to R2, it will not modify the next hop. That's why next hop is showing 1.1.1. But there are two paths. If you will open it in detail, you will understand that one is coming from R3, one is coming from R1. One is coming from route reflector and one is coming directly from R1. Which path is the best path? This path is the best path. Right here you can see we have only a star symbol. I don't have greater than symbol, means this is only valid node best, and this is valid as well as best. Let me open this in detail. So IP BGP 10.1.1.0. Here you can see both path 1, 2, and coming from 3.3.3.
If you enable next stop self command, then what happens?
Next hop self command will not work on R3, sir. Next hop self command is for border
Sorry,
router.
you said border router. Sorry.
Yes, if you want to update next hop, you have to configure route map. Here you can see when it is coming from 3.3.3 and when it is coming from router 1. What is the difference? There is cluster ID. There is cluster ID and originator IP address. This is how you will differentiate the prefixes coming from direct neighbor or from the route reflector. This is reflected route or not reflected route, learning from direct BGP neighbor. So if a route has cluster ID is attribute originator ID in the path, that means this path is coming, this prefix is coming from my route reflector. This is nothing but, you can see cluster ID is a BGP attribute. Which router add this attribute? Only route reflector router. And what is cluster list? This is nothing but the router ID of route reflector router, RR. And what is the originator ID? Originator ID is the BGP router ID of actual originator, who is originating this prefix. Who is originating? Router number 1. What is the BGP router ID of router 1? 10.1.3.1, highest IP address of loopback interface. Yes, na? Here if you will check, so IP protocol, you can see my OSPF routing protocol, and here is my BGP routing protocol. So IP BGP neighbor and 2.2.2.2. Here you can see remote router ID is 20.1.3.1, highest IP loopback interface IP address on router number 2, and local router ID is 10.1.3.1, router ID of router number 1. You can configure router ID as well manually. Here on router number 1, I can say config T router BGP yes number 100 and BGP router ID 1.1.1. On router number 2, config T router BGP yes number 100 and BGP router ID 2.2.2.2, like this. Clear IP BGP star SOP in and show IP BGP 10.1.1.0. 10.1.1.0 is not in table, soon it will learn. So IP BGP, so IP BGP summary. Prefix is not best on R1 now. So IP BGP, soon this prefix will become best. Just give me 1 minute, guys. Okay, now best go to R2 and check. So IP BGP. Now you can see two path. If I will open it in detail, you can see originator ID is not changed to 1.1.1. Okay, my question is this. Here I have two path on router number 2 to reach 10.1.1.0/24 network. How it is selecting best path? You can see this path is the best path. In this path we are not able to see best anywhere. Here is the best. It means this path is the best path. By default BGP doesn't support load balancing. So how it has selected the best path? That is best path selection in BGP using attributes. You can see some attributes like metric to reach next hop IP address. This is what metric? IGP cost. So IP route 1.1.1. What is IGP cost to reach 1.1.1 from R1 to? This is IGP. IGP cost to reach next hop is also one BGP attribute. Next hop IP address. This is also one attribute. Origin code is also one BGP attribute. Local preference is one BGP attribute. Originator ID is one BGP attribute. Cluster list is also one BGP attribute. ES path is one attribute, but here we are not able to see any ES path because we have IBGP session. So guys, tomorrow we are going to understand best path selection in BGP, and here you can see all these 12 attributes. BGP uses these attributes to select best path. Next hop is very first attribute, then wait, local preference, self-advertised, ES path, origin code, metric, external over internal. By the way, earlier also I had told you external route will be for our internal route. So this is 8th number of BGP attribute. Then IGP cost to reach next hop IP address. These are actually BGP attributes and these are tiebreaker. What if multiple path has same all 9 attributes, these first attributes? Then what it will? BGP doesn't support load balancing. In that case, how BGP will select best path? BGP cannot install more than one path. So these are the tiebreaker. Oldest path, like your oldest friend is always best friend. Oldest path is going to be always best path. Then lower neighbor router ID. Router ID is unique. It cannot be same, right? So based on neighbor router ID also it can select best path and lower neighbor IP address. In some case it will use lower neighbor IP address, sometime lower neighbor router ID, sometime oldest path for tiebreaker. Otherwise attribute number 1 to attribute 9, you can see these are BGP attributes which we need to not only understand, which we need to master, like EBGP, OSPF. It's time to understand best path selection in BGP. Okay, so we have prepared the topology as well. In same topology we can understand best path selection. That's all from my side for today class. If anyone have any question, please ask.
Sir, I have a good question.
Go ahead.
Can you please open the lab that we were working at the beginning, that provider lab, provider cloud lab?
I have closed that lab. Ask me. Here it is. Later.
What I was trying to see in that lab, you said we can do one side IGP and no, we can do one AS number on the one branch and the different AS number on the other side of the branch, and then IGP in between. I was trying to understand how we can do the BGP pairing, uh, BGP pairing between one AS to the provider side and different AS with others branch with different provider.
This was my topology.
Yes, sir. There was one router. If you implement in the middle also, please. R3, right? Yep. R2. And now if you go on the left side for the R1 with another CA customer edge router.
Okay.
Yep. And now if you connect that, right? Yep. So CH1 on the left side, if we have one provider, right? And CH2. Okay.
Okay.
So ACE number on the left side is 100.
Okay. Here.
On CH, sorry, on CH, sorry, CH 100.
Okay.
And then
200.
100. There is
100.
100 also. Yes.
Okay.
And then now if you router 1 is Airtel and router 3 is any other provider, right? So consider a 500 is down on the
Okay.
R1 and then 600 just for example.
Okay.
So now we have two different providers, R1 and R3. The one that in our lab we were working on 500 was the one provider cloud, right?
Okay.
So I'm trying to understand how we are going to get these two exchange routes in between.
So it is like how routers are going to advertise out to their EBGP neighbor.
Okay, like 100%, right? Is there anything that is missing that I need to be specific about when we are working with the different autonomous systems? I know we covered already all those setups, but in terms of provider network, I was trying to make sure I'm covering all those gaps also.
So there is nothing, no need to configure anything, just test it. What is this? There is no
Just
any
test it.
question, bro. So if I'm running 500 and 600 here,
Yeah.
what is so special? Nothing is special, it is
So
same.
so underlay will be OSPF no matter what.
Yes, definitely.
Okay. Okay. Yeah, then I let me implement this with the different AS numbers and I will get back to you then.
Sure.
Okay. Thank you, sir.
Anything else, guys?
So are we done with BGP? What's our next topic?
No, we are not done with BGP.
Oh, BGP is deep.
We still need to go with all those
Okay.
parameters that you're seeing on the screen.
Any other question? Anybody?
Not for me, sir.
For this? All good? Okay, then set up this lab in your simulation, right? Do the basic configuration and we will be testing. We'll be learning best path selection here from tomorrow.
Thank you,
Bye-bye,
sir.
everyone.
Please share
Bye-bye.
the
Okay.
recording and
Yes.